These three graphs represent functions. We can see that they are functions by this vertical line test that we mentioned in another video, right? If we draw a vertical line through any point on each of these three functions, it would pass through exactly 1 point on that graph, which means that it's a function. If it passed through more than 1 point, then that would mean it's not a function. Then there would be two outputs for every input. What we're mostly interested in is to be able to find the domain and the range of each of these graphs. As we're doing so, I want to mention the types of functions that we have for each graph. Starting with number one, we have this parabola that crosses the x-axis at -1 and 3. It also passes the y-axis at -3. And this function, since it's a parabola, this function will be quadratic. Quadratic meaning that the degree, the largest exponent of the function is 2. And if we were to set that function equal to 0 and solve for x, that would give us these x values. You may want to try that on your own, just to see the correspondence between the x-axis, the x-intercepts, and the solution of the function when you set it equal to 0. But we just want to know the domain of the range. All right, and finding the domain of the range by looking at the graph. So the domain is all possible x values. All right, so this is, we can find this by reading the graph from left to right. Since the x-axis is the horizontal axis, we're going from left to right. And so we're saying, what is the smallest x value that this graph can be? Now, these arrows just represents that it keeps going, right? This is a picture of the graph, but we can't draw the entire graph. So we put these lines, these arrows, meaning that it keeps going up and it keeps going to the left and to the right. There's no restriction on what the domain can be. There's no holes, there's no jumps, there's no asymptotes. This is a clean, nice, well-behaved function. And so the domain for this case is all real numbers. And that's the case with any polynomial function that you have. If a function is a polynomial, then the domain will always be all real numbers, negative infinity to positive infinity. Okay, what about the range? Well, the range is all the possible y values, right, where the y-axis is the vertical axis. So when we talk about the range, we're looking from bottom to top. What are all the y values that are covered on this graph? So we can talk about what's the smallest y value and what's the biggest y value. Well, the smallest y value would occur at this point right here, which is -1, -2, -3, -4. All right, that point would be, in fact, 1, -4. That's the vertex of the quadratic function, by the way. We're going to spend more time on quadratic functions in the next section. And so the smallest y value is -4, right? And we can include -4. Right? -4 is the smallest y value, so we're using a bracket because we're including the -4. And then what's the largest y value? Well, these arrows again means that it keeps going up. So there's no bound on how large the y values can get. So we'll write that as infinity. -4, infinity, bracket around the -4, parentheses around the infinity. And there's no jumps, there's no breaks in the graph. So that would be our range, right? All the outputs can be anywhere between -4 to infinity. All right, number 2. This is a radical function, excuse me. This is a radical function when you see the square root for the radical, a radical function. This will have some restrictions on the domain. Looking at the graph, we can we can ask ourselves, what's the smallest x value? What's the largest x value? Well, the smallest x value will occur at this x equal -2 point. That's -2 comma 0. So the smallest x value occurs at -2. And what's the largest x value? And also look for any breaks in the graph. There's no breaks in the graph. That's all continuous. And the arrow is telling us that it keeps going to the right. So there's no bound to the domain. So the domain is -infinity to -2 to infinity, where we're including the bracket around the -2. Parentheses always around infinity. But what about the range? What is the smallest y value? The smallest value going from bottom to top, the smallest y value occurs at this point also, which is 0. We can include the 0, so we'll use brackets with the 0. And what's the largest y value? All right, this graph is moving to the right and it's moving up, and the arrow means that it's going to continue moving to the right and moving up without restriction, without bound. So the range will go from 0 to positive infinity. And then number 3, this is a very interesting type of function. This is a piecewise function. All right, so you have 2 different functions put together. We're mashing them together to make it the same function. So we have 2 pieces to this, hence the name piecewise function. So this piece here corresponds to this function, this piece of the function 4 minus x, right? This is 4 minus x when x is less than 2, right? Here is x equal 2, all right? So 4 minus x, the graph is defined as 4 minus x to the left of x, equal 2. And then 2x minus 2 would be defined for x greater than or equal to 2, which would be this piece right here. Right? That would be the graph for 2x minus 2 when x is greater than or equal to 2. Okay, what about the domain here? It works the exact same way as the previous functions when we're looking at the graph. The domain, what is the smallest x value? What's the largest x value? And are there any holes or jumps or asymptotes? In this case, we've got an arrow going to the left, meaning that the domain will start at -infinity. There's no jumps, no holes, right? That's a continuous graph right here. And it keeps going to the right. So that'll be positive infinity. The domain is -infinity to positive infinity. And that's because the 2 pieces of the function is, both of these pieces are polynomials, which has a domain of all real numbers. Okay, and then the range. Right, what is the smallest y value? Well, the smallest y value would occur at this point here, which is 2, 2. So the smallest y value is 2. We can include 2 here. And then what's the largest y value? Well, the y values keep going up with the arrow. So that would be 2 to infinity for the range.